Now our last example here is one that we get from an expression called the position function. Basically talks about the location of an item or the position of the item after so much time. So let's see if we can factor this one. And what's unique about this one is you notice that I have a negative coefficient of the leading term. So what we want to do is factor out a negative value if we can. So I think a negative 16 is consistent or is factored in each of those terms. So let's factor out a negative 16. And then what's left is I have a t squared minus a t, and 16 goes into 96 6 times. And so I have a negative 6 right there. And let's just double check and work our way backwards as a check. Negative 16 times t squared, negative 16t squared. Negative 16 times a negative t, positive 16. Negative 16 times a negative 6 equals a positive 96. So that checks. Can we continue to factor? Yes, we can. So let's look at this trinomial. Let's assume it factors into two binomials. The first term is the first term squared. Notice it's a t squared this time. So we're going to make our first two variables t's. Then we're all the factors of negative 6 that add up to negative 1. So let's lift those over here. Looks like 3's and 2's as well, don't they? So let's do it. There we go. Those are all the possibilities to create a negative 6. Now, do any of those add up to a negative 1? And it looks like it's this third set here that do. So my factorization then would be t minus 3 and a t plus a 2. And so now I can say that I completely factored that leading trinomial that we worked with. So are you guys feeling all right with this? Okay, please practice. Practice makes better. It doesn't say makes perfect. Good practice makes better practice. Makes almost perfect. So we'll go with that. All right, guys, go at it.